Hi folks, this is Tom. Today we're going to test a really unusual device. This is a Mcintosh Electric Corporation model 5018. They call it a wall plate. The government military technical manual calls it a sinusoidal machine, but for all practical purposes, this is actually an electroshock therapy set. I don't know why they call it these different names here. It's a mystery to me, but maybe even when this was made, probably back in the 40s, they were trying to whitewash things. Okay, this piece of equipment operates both on AC and DC, but we're only going to check it on AC here today. What we're going to do is connect up a 110 volt isolation transformer. And what that does is disconnect this continuity-wise from the AC line. Okay, folks, the output over here of the machine goes to a 1,000 ohm resistor in series with a 1 ohm resistor. So what's going to happen is this is going to measure 1/1000th of what this is. We've got the oscilloscope here dialed into 10 millivolts. And what that's going to do is essentially measure 10 volts for each one of these scale graduations here. So this way here we can see what it's going to do DC-wise. On AC, we'd have to crank this up to 50 millivolts per division. Importantly, we can see what's going to do DC-wise and also how this is going to chop the voltage when we go over here to secondary Faradaic. Okay, the voltmeter here is actually across the entire device, so this is going to measure actual voltage over here. The machine itself operates off of an 83 rectifier here for the DC setting. The important thing with this is a mercury vapor rectifier tube, and you cannot put a load on it when it's cold because it may actually flash over. We're going to plug this in, turn it on, and what you're going to see is all of a sudden this tube is going to have a metallic surface on the inside. A mirror-like surface. What that is this mercury that's in there being vaporized, and the problem is when it covers the inside like that, you can have this entire thing flash over, and that's not good. So what we have to do is we have to wait till the mercury becomes vaporized, and at that point we can put a load on it. Okay, I've got the 83 rectifier here. It's a 4-pin socket. You basically just push it down in, and there it is. The only time this is used is here in the number 1 and the number 2 position, and the number 3, it's not used there at all. Okay, the number 1 position here is DC current that's run through the 83 rectifier and has a 2-section capacitor in there. The original cap, oddly enough, had a plug-in socket, just like the 83 does. We tried to reform this. I've got a couple of videos up, parts 1 and parts 2, where we attempted to reform the capacitor, but the capacitor's junk. So what we've done is we've actually, ironically, taken an 83 tube socket, broken the tube, salvaged the socket itself, and put 2 replacement capacitors in there and soldered them in. So we actually have a brand new capacitor, 2-section capacitor inside the machine here. So on position number 1, we're going to see DC. Position number 2, we're going to see what they call secondary Faradaic, which is basically this vibrator or interrupter contact here interrupting the DC. And what that's going to do is going to show all sorts of crazy stuff on the scope here. And number 3 is just straight AC. Number 1 goes through the meter here. Number 2, you can meter that as well, but it's not going to be very accurate. Number 3 is without meter. This thing will go up here. On DC, I've noted that the 120 milliamp scale is actually off by a factor of 2. When it says 120, it's actually about 65 mils. And when you actually go to the low setting here to 12 mils, it's almost accurate. 12 mils is actually about 12.88 in real life. But bottom line is that's a lot of current, and I definitely would not want to come across this thing. Okay, and it will peg this at 120 so-called milliamps here. And when you take this to number 3 or any of these other settings on the other side, on the DC side, which we're not going to test, they do work though, you can take this well beyond 120 and actually go up to 180 mils there. Not on this one here, but on 2 and on 3 especially. So you got to be careful with that. Okay, I'm going to show you the power plug. This is a Hubble miniature connector here. I've got just 2 clip leads and an AC plug going into the transformer here. And I've got the VAC back here dialed to 115 volts, and that's going to supply current to this. Let's go ahead and we're going to turn this on. There we go. And the selector switch over here does not have détente on it. So what you do is you turn it until you hear the thing actually humming. Ooh, there we go. You saw that flashed over. We've got this on 0 here right now. You see that's warming up. And look at that. You can see the mercury blooming already. Let's take this through and we're going to go to number 3. This will turn the filament on, but it won't put any voltage on it. So I think probably the safe thing to do here is to start it from off, let it warm up, or start it from off, go to 3, let it warm up, and then go back to 2 and to 1. Wow. Okay, we'll come back here in a few minutes when it's warmed up. Okay, folks, I don't like that rectifier. We're going to stick the original rectifier back in here that this had. This has got some loose plate material, but that shouldn't affect this at all. We're going to go ahead and drop this in here and let this one warm up. Let's see how it goes. There we go. That's in there. Now we're going to turn this to number 3. There we go. You can see how that's beginning to silver up here as well. The reason I use the mercury vapor rectifier instead of a high vacuum rectifier is that the mercury vapor tubes have a much lower voltage drop. This tube here probably has about 15 volts drop per plate, whereas if this were a high vacuum rectifier like a 5U4 or 5R4 or similar tube, you would have 50 to 75 volts of plate drop there in operation, and that's going to be an issue, especially when you're running at lower voltages here. You can see that's definitely mirroring, and here in a little bit, it's going to burn all the mercury off, and once the mercury is vaporized, then we can put power to it. This one definitely seems to be operating better than the other tube does. Okay, folks, we're back. It's been about 4 minutes. If you look, you can see there's a little bit of mercury left on here, but it's not the solid cloud anymore. It's just a trace of where a couple of drops have gone along there and basically haven't vaporized yet. Okay, we're on 3 here, and if you look right down here where the filaments are, you'll see there's no blue glow. It's just that the normal light of the filament. Watch what happens when we go to number 2. You're going to see the vibrator kick in, the interrupter contact, and you'll see it glow blue as well. There you go. See that? That means we're pulling a little bit of DC there, and now we're going to go on number 1. And number 1, it's definitely turned color here. You can see we're definitely pulling a little bit of current. Okay, now we're here at 1. Let's go ahead and fire this up. Again, we've got the oscilloscope here. We're going to run this up slowly but surely. If you look here on the oscilloscope, you can see the oscilloscope is going up. And again, each one of these divisions is 10 volts DC, equivalent over here. And if we look, let's go back down to 4. That should be 40 volts. And we're about 38.65 here in the digital world. And it says right there about 70 mils, so it's about 35 milliamps. Let's run this to the point where it's 120. There's 120 milliamps on the meter. It's actually only about 65. And if you look at that, 66. And if you have a load, I equals E divided by R. 66 divided by 1,000, about 66 milliamps. And if we look up here in the scope, 1, 2, 3, 4, 5, 6, it's about 6.6. And there's just a little bit of ripple on that. So looks like our capacitor is doing its job. This is doing its job here as well. So that is number 1, galvanic from rectifier. And let's back this down. If we go down to here, I can kick the meter in, and there we go. There's our actual 12 mils right there, if you look. And that says 12.63 or 62 back and forth. And there we go right there. You can see we're a little over 10. It says about 14 there, but that may be just because of where the 0 is. Yeah, I've run the 0 up just a little bit from the bottom. If I put that right there, there we go. That's closer, a little over 12 volts. And there we go. So that looks like the 12 milliamp, the low scale is accurate. We'll kick this back on polarity. Oops, sorry, wrong switch. Kick this back on high. And again, run it up to 120. And there we go. Okay, now we're going to drop this down. Now we're going to put this on the second setting here, which is secondary Faradaic, which you'll see that we've got some, we're pulling off of the tube here, but it's also going to be interrupted by the vibrator contact there. And there we go. And if we look here, wow, what a mess that is. Look at that hash. That's a 0 line. So this thing is actually going negative here as well. And if I stop this for a second, I'll bring our 0 line to right there. That's going to be our center. Everything above that's positive. Everything below that's negative. Turn this on. You can see that there must be current going into the coil, and it's collapsing. So it's building up and collapsing. So we have 80 volts peak to peak here. 40 positive and 40 negative. It's just a mess. If you look at this, that's all over the place. And if we pop this, let's see what happens if we put this on AC. It says you got 23 volts AC there, kind of, sort of. And that pretty much matches up with what we're seeing here. If you take the RMS into consideration, where that half there is actually about 40 volts. And if you divide that by the necessary 1.414, that is about 28 to 30 volts RMS. But what a mess that is. Okay, let's go. Okay, we're back on AC. Let's put this thing over here. We're going to turn this thing down. And here we go. You can see the mercury vapor rectifier has no flash, has no blue in there, so we're not using that. Now we're using rapid sinusoidal, which is basically 60 hertz line current. If we look over here, again, we're in the center. Whap. We got 43 volts right there. I've got to actually step this thing up right there. And holy crap, this thing will actually put out essentially 102 volts. That's freaking scary. So let's see, about 100 mils right there too. So that's scary as all get out. I wouldn't want to have anything near that going through me. And we'll put it back over here and shut it off. Done. Thanks for watching, folks.